All right, let us begin. Welcome back. If you're a returning visitor, this is my ELM test prep series. This is part 38 at this point. I'm James S. Let's get to the task. We're going to be looking at graphing quadratic equation. The ELM test usually has several questions where they give you a formula and they ask you to determine which graph correctly describes that equation. As it turns out, some of them are quadratic equations. So let's just take a brief moment to look at quadratics. The most fundamental quadratic equation is y equals x squared. There's no other terms involved, just the x. And you would graph that as if this were 0, y would equal 0, so I have a 0, 0 vertex point, and my graph goes up from there. If I were to add or subtract some x value, or possibly add or subtract some constant to that, that would then move this vertex point. The constant would move it up or down. So if I had some constant here, it would move that vertex up or down. This term would move my graph left or right. And so the vertex could possibly be left and up, left and down, right and left, and so it could be almost anywhere. The only other major thing that we want to talk about with respect to the quadratic is what happens if I have a negative x squared. So if I have a negative x squared, my graph will look like this. Oops, sorry about that. It should have gone through 0, 0. I'll just draw it down like that. It'll look down. It'll be a downward shaped U. So the negative causes my U to go downward. The positive out here would cause it to go upward. So having the general shape, and what causes the leading term, the leading coefficient of x squared, will cause your general shape. The other terms in the equation will tend to shift it and modify that shape a little bit, but not that much. All right, so let's try a basic fundamental graph. Y equals 2x squared minus 3x plus 4. Okay, so one thing I know is if I let x equal 0, these terms go to 0 and I'm left with y equals 4. So I will have a point on my graph there at plus 4 on the y-axis. So the question then is, where is my vertex? Is it over to the right or to the left? And since this is a plus, I know it's U-shaped up, and so the vertex will be the lowest point on that graph. So part of the quadratic formula is minus b over 2a. And that part of it determines the x value of the vertex. All right, so minus b, what's b? This term right here with the x is b. The a is this term, the coefficient of the x squared term, that's your a. So if I divide b by a, or in more specifically, negative divided by a plus, that would be a negative. But I have a negative out front of this whole equation here that will then say take the opposite of those two signs together, and we'll change it to a plus. So what that's going to say is that my vertex lies somewhere over here on the plus side. Well, the vertex is the lowest point, so it has to be below that point, so I'll pick some point below that, and then I'll graph up, and I'll go through that point, and that will be what my graph looks like. Now, the questions that talk about the graphs don't specifically ask you to graph every point. They don't want you to specifically know that the vertex is some y value along there. The only thing you need to know for this test is that the vertex is the lowest point on a U shape, upward U shape, and so that point has to be below whatever your y-intercept is. Okay, so let's try something else. Let's try another one and see what happens with that. Now typically they'll give you 5 graphs. Graph A, graph B, graph C. And one might be something like this, and one might be something like this, and one might be something like that, and so I might even have some that are negatives. Well, since it was a positive graph, it was a plus x squared. I know that it's shaped up, so this is gone and this is gone. And I know my vertex was to the right, so this one is gone. And so this one is the only one that looks to the right, and this looks centered, so I'll throw that one out, and I will then have my answer. It's not an exact point-by-point graphing here. We're looking at general shapes. So let's try another one. Y equals minus 2x minus 3 plus 3. So put down our x and y axes. And the first thing I want to do, oops, I forgot my x up here. I apologize. And I forgot my square. Oh my goodness. I'm getting tired, I guess. All right, so what we're looking at is it's a negative x squared term, so I know my graph is U-shaped down. I have a plus 3 here. If I let the x's equal 0, I'll have a plus 3, so I have a point above on the y-axis. I have a point up here somewhere. Well, I know that this vertex is the highest point, so I know that it's going to be above this point on on one side or the other. So let's look and see which side it is. Okay, so minus times a minus is a plus, and we said we're going to take the opposite of that because of the minus b over 2a. We're going to take the opposite of that, so our vertex is going to lie somewhere over here on the left or negative side. So we're going to take the opposite of that and we're going to put it on the negative side. Well, it's the highest point, so coming out of here it has to be above that point, and then it will go down and down, and I have my graph. So I want to find a graph that looks like this. Like I say, these exams will give you 5 choices. You should be able to throw out anywhere from 2 to 3 simply because they're going the wrong way. We're looking for downward graphs, and we're going to have some upward graphs, and we're going to throw those out immediately and then compare what's left. And we're going to look for, does it go through the plus 3 point, and is the vertex on the left of the y-axis? So this is not a rocket science game. You want to be ballpark. You want to be able to just stand in the garage and throw the ball and hit a wall. So, all right, we're moving on. Okay, so we have a little time left, and I'm just going to review why we're doing what we're doing. Let's say we have y equals 3x squared plus 2x minus 4. Step 1. I'm going to look at this and see what kind of curve I have. It's a plus, so I'm going to have an upward graph. Step 2, I'm going to let x equal 0. Well, if I let x equal 0, these terms all go to 0, and I'm left with a minus 4. So I know it's upward. I know I have minus 4 on the y-axis, so I'll put a point down there somewhere. And then my final step is to look at vertex minus b over 2a. I'm going to look at these two signs here, put them together, multiply them or divide them either way. Plus divided by plus is the same as plus multiplied by a plus. So if I look at multiplying those, plus and plus, I get a plus, and then I'm going to take the opposite of that, and I'm going to put my vertex on the negative side of the y. My final step, of course, is knowing that the vertex point is the lowest point. So I'm going to plot the vertex. And so it's the lowest point. I'm U-shaped up, so it's the lowest point, so it has to be below this point. So I'm going to put a point down there, and then I'm going to go up, and I'm done with my graph. It's that easy. Now, certainly in a math course, they would ask you for a lot more information. They'd want to know exactly what the xy of that was. They'd want to know the xy value of those 2 points. But that's not our job here. We're just looking at the general shape of a quadratic. That's all they want you to get out of this. They want you to know this determines my intercept, my y-intercept point, and these two things determine my vertex. And the sign out front here determines whether I'm up or down. That's the main thing they're looking for, is this general idea of what a quadratic equation looks like on a graph. All right, we've pushed our time envelope again. Hope this was informative. I hope you learn to just try a few of these and have fun with them. And good luck on your exam. Have a good day.